Okay, so I'm just going to continue where I left off. There's a few more things that we're going to talk about, and then I'm going to give you, I know I said I was going to give you a quiz, but I'm actually going to give you homework because it was like, it's a pretty complicated amount of work. So just to go over this, so we already talked about overloading, right? That's where you create another method that takes a different parameter list, but has the same name as an existing method in the class. And then we talked about overriding. This is where you create a new method for a method that was defined in your parent class, right? So every class inherits from the underlining object class in Java, and the object class comes with the methods equals and the method toString, right? You guys remember that? We talked about that, and I gave examples on that. For those that missed class, I did post a video. I got it up like late last night, so it's there now. But whenever we make the toString method, we're actually overriding our object class's toString, and then whenever we create our equals method, we're overriding our underlining class's equals method. Okay, so the object class has an equals method, and it just basically checks to see if it's the same object in memory. But we modified the equals method for this account so that we can just check to see if the data was the same, like the account name matched, if the account number matched, and if the balance matched. Then we said that the objects were equal to each other, and then we returned true. Okay, so I know like there's a lot of things in here that we haven't covered yet, like the double equal sign, the %, the double %, like this little construct right here with the question mark and the colon, right? And we're going to talk all about this in chapters 5 and 6. So that's when we're going to learn about some of the stuff inside of here. Okay, so let me hop back over here. We did talk about this. You guys remember what I said about this? Like, what does this mean? Like, what is it used for?
It specifies the instance of that object in the moment of its first use.
Exactly, right? So the way we used it is there's this ambiguity whenever you use a constructor or method that uses the same variables, right? Like basically I'm saying, here's my constructor account. I'm taking in a string for the name, a long for the account number, and a double for the balance. But I use the exact same names that I used for my instance data up here, all right? So without this right here, Java is like super confused on what to do. So what it actually does is it takes this string and assigns it to itself. I'm gonna close the door. All right, so that's what this does. It just basically allows you to reference the current instance of the object. So we could have also used that down here in the equals method. I chose not to, but I mean, maybe it's a good idea, right? So I'm saying like the name on this account, the account number on this account, and the balance on this account, right? So it just references the current instance of the object on which you're invoking these methods, right? So if you invoke this method on like account 1, then this is going to refer to the object instance of account 1, right? Because in this equals method, you have account 1 and then you passed in account 2, account 3, or some other account, right? So the other object coming in is the instance of the other account, right? Does that make sense? I don't know. You have to keep, I mean, programming is one of those things where you can read about it all day, you can listen to somebody talk about it all day, but if you don't actually practice it every single day, then you're never going to get good at it, right? Like, you're going to have to start making your own equals methods and using this, and then like the more you program, the more and more this is going to make sense, because it's just basically syntax that you're giving to Java to make your program behave a certain way. All right, so I guess that just leaves us with utility methods, util methods. Hold on, let me think about this. Is there anything else I wanted to talk about? I don't. Oh, Java docs, but I'm going to leave that for. I'm going to make you guys read about that. I'm going to talk more about inheritance as well. It's not actually. We're not going to go like full on into inheritance. That's something you cover in the next Java class, but since every class does inherit from the underlining object class, we're already practicing inheritance because we're having to override our toString method and our equals method. So I'm just going to kind of talk about it a little bit because the term inheritance is also going to be on your final exam, so you're going to have to actually know what it means, right? But when you get into the next Java class, that's where you're going to actually do a lot of inheritance, okay? So maybe I should just talk about that now since it's on my mind. So the idea of inheritance, okay, is essentially we have this class that's defined, that Java defined for an object, right? It's called object.java. Okay, it has all its information here, like its methods and like whatever data it keeps track. I don't know, I've never actually looked at it. But what inheritance is when we come over here and we define a count, okay? We don't actually put extends, right? Like if you wanted to inherit from a different class, you would put extends and then the name of the class, right there. We don't actually do that because Java auto does this for us. It's kind of like the way when we use strings, it automatically calls the new operator and the constructor for the string class, right? It's just one of those things that is done so frequently that there's no point of having syntax for it, okay? So a count is actually inheriting from the object class. So what that means is this account class is a child of this class, right? So this is a parent, and this is a child. Oh shoot, what the heck? Okay, so what's happening is this child is going to inherit everything that the object class has, right? Like whatever things that you put inside of your object class, the account class is going to inherit. That's why we're able to call the toString method without actually creating the toString method in our account class. We're able to call the equals method without actually creating an equals method inside of the account class, right? So things that you inherit are the toString method and the equals method. And there's some more methods. One of them is like hash or toHash. I forgot the name of the method. Something with hash, I don't know. I don't use it enough to memorize the name. But there's a few methods that you actually inherit from your, let me see, let me put that there. You inherit from the object class, right? So that just means that the account class is an object, right? Because it comes from the object class. So this is what we call like the is-a relationship. So the account class is an object because it inherited from the object class. So the account gets all these methods or whatever you described inside of here to into the account, right? Now, if you think about this, and we'll talk more about this in Java, the second Java class, this actually can save a lot of programming. So I know there's a lot of game developers or a lot of people who are in the game development program. So if you think about it, if you can define just a generic enemy class, right? So just say you have this generic enemy class, it's right over here, okay? You can actually create instance data and methods that every enemy is going to have, right? So every enemy is going to have like health. Dang it, I'm really sucking at writing right now. That's not the erase. All right, so every enemy is going to have like a health, right? An integer for health. They're probably going to have like a damage ratio that they can give out, right? So damage, right? They're also going to, I mean, in a video game, you're going to have like, you know, like the model and the, I don't know, graphic stuff, right? All that's going to be defined in here. But some methods that the enemy can do is it can attack you, right? So there's going to be like an attack method. And then it's going to, I guess, take damage. I don't know how you would label that method. It would be like take damage. What's that? Well, battle is more of, I don't know, not really taking the damage. Right, so like these are services that you can invoke on the enemy. Like if you're the character in the game, you can attack it, or it can also take damage. Well, actually, the attack would be him attacking you. I don't know. You can figure all that out, right? The programmer's writing the method, like he's going to define like what actually happens in these methods. So you define this generic enemy class, and then from this class you can pass all these instance data and methods that you just created in your enemy class to other classes that give a more detailed description of an enemy, right? So just say this is like ghosts and goblins or something like that. So maybe you have like a vampire up here, right? So the vampire now, even though you didn't actually create any data for this vampire, it already has a health, damage, it has an attack, it has a take damage. But what you're gonna do up here is like maybe create instance data that's specific for a vampire. I don't know, like his sleeping hours, or I have no idea what your game's about, right?
Like getters and setters?
Well, instance data and also getters and setters, and also special methods, right? Because the getters and setters only gets and sets our instance data, but the vampire will be able to, like, I don't know, transform into a bat, right?
So extra methods in there.
Right, in addition to the getters and setters, right?
Yeah.
The getters and setters for health and damage will be defined in the enemy class, and then those methods can be invoked in the vampire because they're already defined in the enemy class. But if you create any additional instance data in this vampire class, then you would make a getter and setter for it,
Right.
if need be, right? So you don't always need a getter and setter for your instance data, right? It's up to you as a programmer to decide how important it is to provide a service that gets and sets that value. I mean, you don't always need to have it, but the way the book teaches it, we always just assume that we need it all the time, right? But maybe there's some instance data that you don't want to set. Like you only want it to be passed in the constructor, and that's it. You don't want to like change it anytime after that. Yes.
So like to put the enemy into the vampire, would you do like how we did like die class? The die class together?
That one, no, it's something completely different.
Okay.
So that example of the die class and the paradise class is actually two classes using each other, right? But this is more of an example of, man, I wrote this name like horrible. Let me see if I can erase this. Okay, so here's our vampire. Dang it, hold on, vampire. Okay, so there's the name of your class. It would be public class vampire, and then you'd call the reserve word extends, and then it's going to extend the enemy class. And that right here is what's going to tell Java that vampire is a child of the enemy. Right, does that make sense? So then it's gonna get everything from over here, and then in the vampire class, you're gonna have your own special methods that are specific for a vampire. One of them, the only one I can really think of right now is like convert into a bat or transform, like, yeah, something like that, right? And then over here, you'll have other things like a werewolf or a goblin or something like that, right? And it's gonna have its own instance data, its own methods, right? But if you didn't have this enemy class, like if all this was gone, just pretend like this was all, like you never created that. For the vampire, you just say, okay, well, it's a video game. I'm gonna need health, I'm gonna need damage. He's gonna have to attack, he's gonna have to take damage, right? And then you're gonna go over to your werewolf, the same thing, right? So anything like that all these classes have in common is kind of like what you wanna push down into the parent class so that you can share that code, right? Does that make sense? So that's kind of like what we do with the object class right over here. We have the toString, we have the equals method. Those are common methods that are pretty much called on every single method. Now the beauty of this is even though this vampire class inherited from this enemy class, right? So this is a parent, this is a child, right? This is a parent over here, this is a child over here. The enemy still inherits from the object class. So whatever the enemy inherits also gets pushed up to the vampire. So the vampire will still have a toString and an equals method defined on it, right? You could still invoke that on the vampire. So you can have like a chain of inheritance and keep pushing those attributes and those methods up to the child. Does that make sense? Okay, so that's inheritance. We're not really gonna go into much detail other than this model right here. You have your object class, and then you have some generic class, dog, account, car. We don't have to specify the extends, right? Because if we inherited from any other class besides object, in our class header, we would put extends and then would put object. Okay, we don't have to do that because it's automatically done for us, right? So just to give you an example of that, going back to my account class that I created, here is the class header. If I wanted to make my account a vampire, there's no vampire class that exists though, so this won't compile. I would just say vampire, right? And now my account's a vampire. This account can turn into a bat. It can take damage. It can give out damage. It has health, right? So, yeah. I know that doesn't make sense, but yeah, okay? But it actually, this class actually auto-inherits from the object class. If you compile it, it still compiles, right? Because Java's okay with you specifying that it inherits from the object class, right? But it's just like unnecessary for us to do that, okay? So we don't even have to put it in there. It's still going to inherit from that class. Yes?
If the vampire class existed or whatever and you compiled it, would it still, like, and you didn't have anything that came from the vampire class? Like, you know, you just have, like, what happens? Does it just show that? Or, you know, like, could you just use that? Or?
Oh, so what would actually happen is, let me open up a driver for this. Let me see, open recent, count test 2. Wait, what the heck? It doesn't exist. I thought I created all this. I went back to mother. All right, that sucks. Dang it! I thought because I thought I put all the demos in Dropbox. Let me check real quick. Wait. Yeah, it's right there. Or no, that's the one I just created. Hey, what the heck? I don't know what's going on. Account test 2, but then this one, okay, I don't know. All right, I'm gonna go to open and I'm gonna select account test 2. Okay, so this is what's gonna happen. If there was a vampire class, you know, I actually can probably do a real example if I go to, let me see, when did I last teach Java 2? Spring 2019. Dang, I don't know which one it is. Polymorphism demo, no, maybe. No, dang, that's not it. All right, look for something that stands out, like, there's one that's what? Oh, inheritance demo, yeah, I think I would put it in there. Okay, here's one. Okay, I made a Goblin class. So I'm just going to copy this and then slap it into our chapter 4. Okay, I'm going to see what this looks like. I don't know what it looks like. Okay, it extends the enemy. I'm going to have to just delete this because I don't have the enemy class on me right now. And I'm calling super. You'll talk about that in Java 2. That's the constructor for get name, set name. We have all that already defined though, right? Dang, that sucks. Because we have all this already defined. So we're basically going to override the get name, the set name, which doesn't make sense. So I'm going to go ahead and just delete this so I don't confuse you guys too much. All right, so it says get gold coin count, set gold coin count, get armor type, set armor type, enemy phrase. It overrides phrase, which was from the enemy class, but doesn't exist anymore. All right, so this is just all the behaviors of a goblin. I know it might not make sense, but I'm just gonna kind of just make my account a goblin. Okay, so I'm gonna come over here and I'm gonna say that the account extends goblin. All right, so whenever I do this, and this has a constructor, it does have a constructor. I don't need this constructor anymore. I think I could just get rid of it now because I don't have name anymore. Oh, you know what? This is not going to compile because it's getting the enemy phrase and it's getting its own name. Okay, so I'm going to get rid of that. Now, I could just drag it over, but I don't want to go through all that because I already like changed so many things.
Is it going to compile even though you're importing something that I don't think is
Well, I didn't import it. I was inheriting, and since the class was in the same spot, the same folder, it just, oh, I got to get rid of this package name.
So that's what I was saying.
Oh. All right, I don't see anything. Let me try to compile. Compile, dang it. Oh, the level. I guess the level comes from the enemy. Let me get rid of this. So does the health. Dang. All right, you know what? Screw this. I'm going to just copy over the enemy as well. Okay. So come over here to Spring 2019, Java, Eclipse demo, inheritance demo. Dang it. Hope I wasn't using that utility class. Okay. Hop over here. Wait. What the heck? Oh, no. Wrong spot. Hop over here. All right. Let me just see what this enemy class looks like. Okay. Let me get rid of this. So the enemy class has a name, has a health, has a level. Yes.
Just the protected visibility modifier.
The protected lets the child class use that instance data without calling the getter and setter. But that's something we'll talk about
But
in
not the driver.
Java 2. Right. The driver wouldn't be able to use it.
Okay.
All right. So here's my goblin. Made the enemy. Get rid of this package. Okay, I think everything should compile. Okay, it does compile here. Where's my cursor? Compile. Yes, good. All right, so I'm going to come to the account, compile. It doesn't want to compile because my constructor for my goblin takes in a name. So that just means, I know this is going to be super confusing. I'm not going to test you on this, but that means I got to call my parent class by calling super and then pass in a name, right? And I'm just going to pass in, you have to call it first though. I'll just call it like Bob. I always use Bob. Sorry, Bob. I'll use Ted. All right. I need that in every constructor that I created. In fact, I'll just take this name that came in and just pass it right here. And then I'll take this name and pass it right there. Okay. Should be happy now. It is happy. So I can come over here to account test 2. I can compile. I could run. And you see that if you look at the account, it doesn't look like a goblin at all. Like it doesn't like, it works just like an account. I inherited from goblin, which inherits from enemy, but it's not doing anything that a goblin or an enemy will do. However, I can invoke methods on this. So like just say if I wanted to, where's the one? Get phrase, get enemy phrase, and then get phrase. If I wanted to invoke phrase, then an account test 2 on like account 1, it returns a string. So I'm going to say system.out.println, and I'm going to say account 1 says, right, and I'll just do account 1, and I can invoke the method phrase because it inherits from the goblin. The goblin has the method phrase defined. I can compile. It compiles, I can run, and then you can see it says, I will destroy you. Hello, my name is Mike. How is your mom doing? Right, so that's what a goblin says, right? If I would have changed the name on account 1, wait, it's nothing there. What do I set the name, right? If I just change it to like an actual Goblin name, I don't really know Goblins, personally, so I don't know what a Goblin name sounds like. What's that? Smeagol? Smurgle? Is it Smurgle? Smeagol? I don't know. You're talking about like the Lord of the Rings or Pokemon Go? Oh, okay. I think Smurgle is from, it's like that French cow, right? Yeah. All right, so this time it says, I will destroy you. Hello, my name is Smurgle. How's your mom doing? Right. So I'm able to invoke Goblin methods through my account class because I inherit from the Goblin. Okay. That's why I'm able to call toString and the equals method without actually defining a toString or an equals method in any class, because every class inherits from the object class. Okay, does that make sense? Okay, it's kind of an important concept to understand. You're going to go a lot more, like Java 2 is going to just take a deep dive into polymorphism, interfaces, and inheritance, right? That's the next step from classes. But for now, the thing that you need to know is that every class that we create inherits from the object class, okay? So in Java 2, you'll do all this stuff here. I don't know what I should do. I should probably just remove it so that I don't confuse anybody. But I'll leave the files there, but I'm going to remove it out of this. In fact, should I delete this? Yeah, I'm going to delete this line. And now I'm going to go to account, and I'm going to not inherit from Goblin class. But I'll leave the Goblin class and enemy class there if you just, I don't know, if you're interested and you just want to play with it. They're there in that chapter 4.2 demos. Yes.
What does super do?
So super is like the reserve word this, except it references the parent of the current instance. Okay. So that's what super does. So whenever you instantiate your object that inherits, if you don't overload, if you don't call the constructor, if it has a constructor defined, then what you're going to have to do is call the constructor from your constructor. And this calls the constructor of the parent, if that makes sense. I don't know. But I can actually, I need to remove this now because this won't compile. Yeah. But if you don't have a constructor defined, then you don't need to call the super. Yeah. All right, any other questions on inheritance before I move on to utility methods? No? All right, so I'm going to go ahead and create another driver class. Let's see, I'm going to save this one as account test 3. All right, so I'm going to make an interactive program where I have a scanner class and I prompt the user for his info and all that kind of stuff. So I'm going to say import java.util.scanner. All right, and over here I'm going to have system. Wait, no, I'm sorry, I'm getting ahead of myself. So I'm going to have scanner scan is equal to new scanner. Listen to the keyboard, and then what I'm going to do is I'm going to create an account, but I'm going to prompt the user for all the data. So I have these 3 constructors that I created. One where I take in a name, one where I take in a name, an account number, and a balance, and then one where I just don't take in anything, right? I'm going to go ahead and I'll use this constructor to start off with, okay? So I want to use this constructor, but I'm going to prompt the user for all the data, right? So what I'm going to do is I'm going to come over here and I'm going to make the object reference variable, but I'm not actually going to instantiate the object, right? So I created the variable, but I didn't instantiate the object. And then I'm going to make some temporary data for the user, like the information I'm going to take from the user. So I'm going to say like user name, initial deposit. Wait, I can't do that. That's supposed to be a double. So username, and then a double for initial deposit, and then an integer for the, no, actually it was a long for the user account number. All right, so I'm going to prompt the user. I'm going to say like system.out.println. Actually, print looks nicer. I'll say enter customer name, and then I'm going to store the customer name inside of username by saying scan dot next line. Okay, and then I'm going to say system dot out dot println, or actually just print. Yes.
Does next line do the same thing as like print line, like how it makes the next, like goes to the next line?
It just reads, it takes in, so the way the scanner works is it delimitates on whatever you specify as the delimiter. So if you don't specify delimiter on the scanner class, we haven't talked about that, but you have to go and read the scanner class on the API. But the default delimiter is white space, right? But what the next line does, it ignores the delimiter and looks for you pressing enter to end the line. So it looks for the end of line character and just reads the entire line as a string. Like if I were to use next, it's going like if I type in use next and I use like Michael, then put in my last name, put a space between there, it's only going to take it Michael and not my last name. Right? So just to kind of demo that, maybe I should just change this to next, and you can kind of see the quirky behavior of using next. Okay, so I'm going to say system out print, enter initial deposit. Right, so this is like if they come to the bank and they want to open an account, the teller is going to get the user's name and then like the amount of money they're going to put into their bank account. So initial deposit is going to be equal to scan dot next double. And then enter, I guess, would you ask for the account number? I guess you would auto assign that, right? So yeah, it'll just get generated. What's that? Yeah, I mean, the bank should actually come up with all that, right? So yeah, I'll just enter it in like, okay, so at this point I have all the data that I need to create my object, because I'm just going to hard code in the account number for now. And what I'm going to do now is I'm going to say, okay, now that I have the information I need for my account, now I can go ahead and instantiate my account object. And I'm going to pass in the username, the initial deposit. I don't know what order all this goes in, though. I'm going to have to go check. And then the account number, I'll just say the account number is 1234. And hop over to my account class. And let me see. Okay, so the account number comes before the balance. All right, so I'm going to move this account number to the middle. All right, and there's where I instantiate my object. And then I'm simply just going to do a system.out.println, and then print out whatever my toString has created for this account. Yeah, so I'm going to compile. Get compiled. I'm going to run. Okay, enter customer name. I'm going to put in my name. Press enter, and then it just crashed, right? Can anybody tell me what happened? So I have next, right? So next delimitates the input by white space. So next actually just took my first name, and then my last name got entered in as the initial deposit. And since the initial deposit is a double and this is a string, it just gave me this message like input mismatch, you know, because it was expecting a double, but it's all a string, right? So if I were to like not enter my name without putting in a space, then this would actually work as expected. come on, zoom in. All right. I'll just put in like Mike, and then I can enter my initial deposit, $45, and then there's my information, right? My name on the account is Mike. My account number is 1234, and then my initial deposit was, or my current balance is $45. If I run this again, I could put in Mike, and then put in like a deposit of $100, all on one line, and then press enter. And since the scanner actually delimitates by white space, it saw Mike and 100 as two different inputs. So as soon as it saw that, it just took in that data and created my account object, and then I just printed out my account. Okay. Now, there's a drawback to this, is that you can't actually put a space in your name. So you would have to use next line right here. All right. So now if I were to run the same program with the same input, I'll type in Mike and 100, press enter. It took in my name as Mike 100. Okay, my initial deposit is $78, and then my object's created it and printed out. All right, any questions on that? I mean, that's all stuff that, we already kind of covered, so it shouldn't have been that complicated. All right, but what I want to do is I want to create a utility method that I'm going to invoke to do some special task, okay? So let's just say that I want to avoid the problem of spaces before and after my name, right? So, and also my amount. If I were to compile and I were to run, okay, I can type in space, a bunch of space here, and then Mike, and then my last name, press enter, and then my initial deposit, I'm gonna go ahead and not mess this up. I'm just gonna put 67, and then you can see that it has my name with all that white space, right? Okay, if I were to run this again and put all this white space, Mike, Mad, enter, put a bunch of white space on the number, press enter, and this converted into a double, but it was able to remove all that white space because it still saw that double inside of it, right? So we don't actually have that, we don't have that problem when we convert it to a primitive data type, but we have that problem when it's a string, okay? So what I want to do is I want to just go ahead and remove white space from this, right? I can come over here and do a trim, but what I want to actually do is maybe make a method that I can just call anytime I want to trim off white space from any string. I can come down here and make a new method. I can say public string, because it's going to take in a string and give back a string. And then I'll call this one, I don't know, cleanup string, I guess. I have no idea quite. Clean up string. And what I'm going to do is I'm going to take in a string, and then I'm going to just say my string is str, it's just some name, and then I'm going to return whatever string they gave me, but I'm going to trim, right? So now what I can do is whenever I do want to trim off all that white space, like right here, I can just pass the next line to the method cleanup string. And what this is going to do, it's going to call this method down here. Actually, I have to make it static. I'm sorry. The reason why I have to make it static is because if it's not static, that means I need an instance of the object in order to call that method. And that means I'd have to make an object called account test3, which doesn't make sense, right? So I make it static. This just tells Java this is just a method that you want to call without having to make an object, right? You're not attaching it to some entity that is going to have state and behavior. By putting static here, I can now just invoke that method whenever I want to trim any string. So now, oh shoot, that went too quick. Now when I put a bunch of space, I press enter, and the enter amount, you can see that, dang it, what happened to it? It went ahead and got rid of all that white space, right? Okay, so you can do that for anything that you want to do. So let's just, let's just say, let's see, we want to prevent the problem of them entering a number. Let's see, minus this. All right, I'm going to go ahead and compile, run. So this is the problem I want to prevent. All right, they enter in their name, okay, and they enter in a value, but somehow they put in some characters in there, and then they put their number in, and they press enter, and then Java gets upset, and then you have a runtime error because it wasn't able to convert their input into a double. So what we can do is we can make a method down here that we can call that will convert a string. We could take in our number as a string, trim it, and then remove any characters, or make sure that there are only, man, how are we going to do this? I have no idea. I haven't really thought about this too far. Because we're going to have to use the try catch, but that's from chapter 11. I guess I'm going to just go ahead and have to use it. Apologize for that. But what I'm going to do is I'm going to make a method called public static. It has to be static. But this time I'm going to return a Boolean. Dang it. Do I want to return a Boolean? I can't return a Boolean. Yeah, I want to return a Boolean. And I'm going to ask the question, is of string a number? Is string number? How about that? Okay. And then I'm going to take in a string, str. And then what I'm going to do is I'm going to use a try. We'll talk more about this in chapter 11 in your second Java class. But I'm just here trying to demo that, like using methods for doing different things. What you want to catch here is the number format exception. And you'll talk more about that in Java 2. Okay, so what I'm going to do is I'm going to try to convert, actually it's a double, right? I'm going to try to convert that string into a double. So there, if you look at the double class, we talked about this. We talked about the wrapper classes in chapter 2 toward the end, or was it chapter 3 toward the end? I don't know, I can't remember. I think maybe chapter 3. But there is, you can, on any class that's a primitive data type, you can call the method value of, and then you can test to see if that is a double. If it can convert this string into a double, if it cannot, it's going to throw an exception. If it throws an exception, it's going to happen right, like it's going to get caught right here, and then you can return false, right? But if you don't return at this try catch, meaning it was able to convert that string into a double, then you can return true here. Okay, so what we can do is come back over here. We're going to have to kind of rewrite this and use a while loop, right? Like keep prompting them until he gets it right. But what I'm going to do is I'm going to take in another string. So I'm going to go over here and create a string, and I'm going to call this one initial deposit string. And this time when they enter in their initial deposit, I'm going to save it into a string, but I'm going to do next line. Okay. And then I'm going to say if I was able to convert that value into a number, then I'll go ahead and do everything below. So is string number, I'll pass in the initial deposit as a string. Okay. So then, and only then, if that value that was inputted was a number, then you're going to go ahead and use that data and instantiate your object and print out the line. So then you still have your initial deposit that you haven't set. We're going to set that equal to double dot value of. I think it would either value of or parse double. One of the two. I think maybe it's both of them. Every language has a value of or parse value, right? For some reason, I think Java does both, though. I'm not sure. We'll find out. Right. So basically, what I'm going to do is I'm going to prompt the user for initial deposit. I'm expecting it to be double, but I'm going to save it as a string, okay? Then I'm going to call the method isString a number. It's going to come down here and try to convert it to a double. It's going to return false if it can't convert it. It's going to return true if it can. So then what I'm going to do is, if this is true, then that means that this was able to happen successfully. So I'm going to do it again and then save that value. And then I'll instantiate my object and then print out the account. If it's not, what I'm going to do is system.out.println, and I'll just say invalid deposit. Okay, and that's what the user is going to see if I cannot convert their value to a double. I'm going to compile. It did compile. That's a good sign. That means the value of is a legitimate method, and I'm going to run. Okay, so I'm going to enter my name. Right, enter my value, but this time I'm going to mess it up. I want to type in a bunch of characters. Press enter. It didn't work. Invalid deposit. All right, so like now I'm able to check to see. I have this method I created just to handle checking to see if that string can be a double. I'm going to rerun this method, and we'll talk more about ifs and else on Monday, so that you know how to use these. It's actually the first thing we're going to talk about. Actually, yeah, it's the very first thing we're going to talk about. Okay, so enter customer name. I'll type in my name, and then value. I'll just put in like $65. And this time, since the number was valid, it was able to create that object and print out the value or call the toString on it. Right, any questions on this? So this is the way that you can create additional methods to perform some service for you where you don't want to rely on an instance of that object. Right, does that make sense? All right, so a lot of times classes like account, right, will have static methods that do the same thing, right? So I could come down here and I can make public static, let me see, void, and I can make some method that is going to, like, it's a method that I don't want to invoke on an object. I just want to call it through the name of the class. So if you make it static, you are able to invoke that method to the name of the class, like we are the math methods. Okay, so I'm going to make a static method for an account. So basically, what I'm going to do is just have this method that I can invoke through the class name and give it an account, and it can modify the account somehow. All right. Let's see. What do we want to do? Let's just say, you know, like the bank is doing really well, and they want to give all their customers who come into the bank, you know, some value of money, right? So what we can do is we're going to make this method called public static void give bonus, and we're going to take in an account object. Okay, and what we're going to do, where is my cursor? All right, what we're going to do is we're going to take that object. We're going to assume that it's not null because it can be null. We're going to deposit, I don't know, some value that we want to give. We're going to deposit, you know, $1,000 for every customer that comes in, and it's going to deposit that money. That money is going to be applied to that account, and then after this call, you'll be able to see that that amount of money is now added to the balance. Okay, so over here, what I'm going to do is once I create my account, I'm going to print out my account right there, and then I'm going to say something like system.out.println give bonus, and then we'll call account, right? Because it is static, we can call it through the class name, and then I'm going to type the command the method give bonus. I'm going to pass in the account that we just created, and then I'm going to print out the object one more time. So I'm going to compile. It does compile, and I'm going to run. give it a name. Initial deposit was $5, and oh dang, what the heck? How do you go negative? Oh, you know what? Because I was messing with it the other day. I don't know if you guys remember, where if I pass in an int, I subtracted when I was trying to demo overriding accounts. So for those that were here yesterday, because this is an integer, right? This deposit method is going to get called right here. And for some reason, I just decided that if you pass in an int, I'm going to subtract it. I'm going to subtract, right? If you give me a double, then I'm going to add. So I have two options. I could either fix this, delete it, or just convert this to a double. I'm going to convert it to a double by doing the 0.0 on it, and then compile that, make sure it compiles, compile, run. And now I can get my $1,000 instead of having $1,000 taken away. All right, there you go. Right now I gave him $1,000. And we can apply this to any account that we create. So you can come over here and make a new account, and then we'll just say account 2. And this is going to be, you know, I don't know, dang, all of the names. We'll just say Rover. I made an account for my dog, and that's the account number, and his initial deposit is $75,000. He's been saving. All right, so what I'm gonna do is I'll do the same prints right here. I'll print out my account, and I'll print out Rover's account, then I'll call give bonus on my account, then I'll call give bonus on Rover's account, and then I will print out both of our accounts. Compile. Dang it. Account 2 expected. Wait, what? I don't see what I did wrong. Let me see. Account 2 equals. Oh, I didn't actually call the constructor. Do you guys see that? Right there. That was missing. Compile. Run. Enter the name. Enter the amount they deposit. So you see Rover's account, he has 75,000. Now he has 76,000, right? So this is a static method I can now invoke on any account that is being passed in. All right, makes sense. If it doesn't make sense, it's because you haven't played with this enough, right? So good thing that I have a super complicated homework assignment that is going to make you play with stuff like this. All right, so this is chapter 4 homework part 2. Let me see, I'll probably make it due like in 2 weeks. I am not going to help you on this, right? Like I'm not, like a lot of times you come up here and I'm like, oh yeah, correct this or do that. You're just gonna turn it into Dropbox. I'm gonna grade what you turn into Dropbox. So I'm gonna want you to actually sweat over this and be frustrated and consider dropping the class, right? Like I want this to be something difficult that you accomplish on your own. I know there's a tutor and all that, but like I think it'll be really beneficial to you, especially on your final, to understand how to do this, because you might have to write this program in the future, like in a month and a half. Okay, so this is what it is. I'm gonna go ahead and read it out. Okay, so this says download the account.java file. Okay, so if you look in our Dropbox course folder, there is a folder called files, and I went ahead and I put an account file in there. It's the account file from the book. So if you come over here, if you follow the link on Canvas, and then you go to you follow that link, it's going to take you to something that looks like this. If you go to files, there is this account. It's basically, I just pulled the example from the book. Okay, there it is, right? That's what it has. The book, it has instance data for account number, balance, and name. It has one constructor. It has a deposit. It has a withdrawal, a fee. Dang it, you're supposed to do the fee. Dang, you already saw it. You could just watch this video and Oh wait, the fee's not here though. Okay, well, okay, so the one with a withdrawal, and then you have an add interest. That was there. I don't think I'm gonna make you use that. Then you have a get balance, and then a toString. You don't have all the getters and setters in here. It's all right. Just go with whatever this class already has. So you're gonna actually add to this class. So what you're gonna do is, if you come over here to these instructions, I want you to overload the constructors, right? So overload means that you just basically create a new constructor, but that has a different parameter list. So if you go to the account that I created that's in the demos, you can see that I have several constructors. I have one that takes it in a string one string, and one that takes in a string, a long, and a double. And then I have one that takes in no data at all. So what I want you to do is make the following constructors. So you're gonna have public account. I'm actually giving you exactly what it's supposed to look like. Dang, I'm so nice. Okay, so you're gonna make these 3 constructors. So the first one initializes the balance, the owner, and the account number as specified. So you're gonna pass in all the data. The second one is going to initialize the balance and the owner, but it doesn't have the account number coming in. So I want you to randomly generate an account number. The third one just takes in the owner name. Oh, dang, what the heck. Just takes in the owner name. You're gonna initialize the owner name, and then you're gonna set the balance to 0, and then randomly generate the account number. Then what I want you to do is overload the withdrawal method, right? Because right now the withdrawal method does not take in a fee. Why does this keep freaking changing? Somebody changing it? Oh wait, this is the text pad. I was modifying it on Notepad. All right, so, sorry. Come over here, actually, dang, where was it? Oh, right here. Okay, so come over here, and here is the withdrawal. I want you to overload this. So what does overload mean? Again, it means you make another method called withdrawal, but you're gonna take in an amount and a fee, and you're going to subtract the fee along with the amount. Okay, so that is overloading. Then I want you to add a method called close, okay, to your account class. This method should close the current account by appending close to the account name and setting the balance to 0. The account number should remain the same, right? So if you call close, it just puts close in the name, like it appends it to the end. It just sets the value to 0. All right, so you're just adding a new method. Yes.
Should close make it to where you can't use like the getters and setters?
Oh, no, I guess you could still be able to, right? It'll just be 0. I mean, you still want to get the account name, right? So you don't have to use any if statements or anything like that. Like we are going to talk about ifs and loops and conditions next week, but this homework is just for what we talked about this week. But no, you don't have to do that. But you know what? I do want you to make this, add a method called static, right? I want you to make it part of the account class, but it's going to be a static method, like what we did over here, right? So it's going to be a method that you don't have to have an object for. You're going to call it on the class, you're going to pass in the account, it's going to close the account, all right? You don't have to invoke it on the object, you invoke it through the class name, all right? And the next one is actually the same thing, pretty much, kind of, not really. A little bit more difficult, but it'll be fun. The next one is to add a static method called add a static method called with the header account join account 1, account 2. So basically what you're going to do is you're going to have another static method that takes in account 1 and takes in account 2, and it's going to merge the two together. So in your account class, it creates a new account object whose balance is the sum of account 1 and the sum of account 2. It closes account 1 and 2. Okay? You have to close account 1 and 2. And then what you're going to do is you're going to return the new account object through the method, right? That's the return type on the method join. The name on the new account is going to be the name from account 1 and 2 concatenated. Concatenated means joined together, right? But you're going to have an ampersand, or you can use an and, or just something that signifies like these two people are now in a domestic partnership, and both of their names are on the account.
Yeah, just ask that.
Oh, dang, I didn't even think about that. Okay, so yeah, you're gonna have to generate a new account number. Did I say that somewhere? Okay. Oh yeah, new account should be returned and have a new account number. We can ask the same thing? Okay. Dang it, I keep hitting Control S. All right. Any questions? I mean, this is a fun assignment. I know it seems difficult, but like this is what puts hairs on your chest, right? Like everybody likes to have hairs on their chest because they did something manly, right? But this is like what real programming is. You have to think and say, okay, what I'm going to do here, I have to make this method, use static, right? Like at this point in the semester, I mean, I know we just covered chapter 4, but like you should understand how to create a class and create objects, right? But now what we're doing is we're just kind of modifying them in a way to where we're making these objects more useful, right? Because you're going to close the account, we're going to join two accounts, we're going to make different constructors to create account objects, okay? This is what programming is about, right? Like just finding these useful methods and ways of creating an account object. Okay, I don't tell you to make a driver, but I think it's understood. I should just put it here. So make a driver that creates account objects and test all its methods. All right, so just like you're basically gonna make a driver. I keep hitting Control S for some reason. I think I'm like working on a file, but anyways, you're gonna make a driver, and the driver is going to create account objects. It's gonna invoke all its methods, like the setters, use the constructors. It's gonna join two accounts together. It's gonna close some accounts. Right? I want you to test. You're using the driver to test your class to make sure whatever you added to this class actually works. Okay. That's the whole purpose of the driver class. Okay? So when it's time to turn it in, you're just going to turn it in, and I'm going to grade you. Like, if I think it's crappy work, you're going to get a low grade. I'm not going to say, like, hey, your variable names don't match what we have in the coding standard. Or if it doesn't compile, you're going to get a 0. Like, that's my rule for people who turn in work in. If it doesn't compile, it's a 0. Like, I should be able to go to one of my students' Dropbox folders. I don't know if I should, let me not use a real student or a student in my classes right now. I can go to this person's Dropbox folder, hit Java 1 and 2 with me. What the heck? All right, and let me look at his assignments. Chapter 5. Let's open up chapter 5. I should come over here and just compile and run, and it should be able to compile and run. If it doesn't compile and be like, I'm not going to correct it, that was supposed to be your job to make it compile and run, right? And if it doesn't, it's just a 0. That's the way I normally grade on quizzes and homework. All right, any questions before I let you guys go? So now it's like we're halfway through the semester. If you don't understand this, the drop date is November 11th, right? But I'm not saying to drop, but like, you know, like this is what programming is about, right? Being able to solve these types of problems. This class is only going to get harder. We're going to go through all the loops. We're going to go through all the conditions. Your programs are going to get more complicated. You're going to have to make like a rock, paper, scissors game, play the high-low game. Like you're going to be expected to retain all this information. I mean, on the bright side though, I mean, we just finished chapter 4, right? So we only have chapters 5 and 6 left, right? So there's only like a few more concepts to talk about. Where's my pin? Somebody take it? Oh, it's right here. So chapter 5, man, I suck at using this. All right, chapter 5, we talk about the if, we talk about the while loop, We talk about that ternary operator, that thing that I showed you where you have some condition, the question mark, some value, the colon, and then some other, right? Talk about 3 things in chapter 5. Chapter 6, we talk about the for loop. We talk about the do loop. We talk about, what else is in chapter 6? Yeah, the switch. So really there's only 1, 2, 3, 4, 5, 6. 6 things to talk about, and then that's all I'm going to test you on, okay? Then the next thing we're going to talk about before you actually leave this class is arrays. So chapter 8, the very beginning of chapter 8, we're going to talk about arrays. I'm not going to test you on arrays, but it is something that you should know going into your next class because you're going to start learning about arrays right away. And I don't like my students to leave my class without knowing how to, or what this means right here. Where's my driver class? Right, we write this all the time, but we don't even know what it does or what it means, right? So when you leave my class, I want you to know how to use arrays. I'm not going to test you on it, but I at least want to teach you. It'll only take like 1 class to teach you arrays, at least what I want you to know. I won't give you any homework on that, but we only have really like 6 things to talk about. We have an entire like a month and a half to focus on those 6 things because the homework is just going to get exponentially more complicated where you're writing like legit programs that actually do something useful.